I'm Yoshiaki Okubo from Hokkaido University, Japan. Today I'm talking about our algorithm for finding music formal concept. In our study, we are concerned with clustering of data objects. Clustering is one of the fundamental tasks in data analysis and data mining. In machine learning community, it is often referred to as a kind of unsupervised learning. Clustering plays an important role in various applications, including recommendation systems and visualization systems. In order to design interesting systems in music domain, we are concerned with clustering of music objects. So in general, many researchers have pointed out that it's very important to provide adequate interpretation of clusters. So in other words, clusters must be conceptual. So it's also true in clustering of music objects. So I think it is more difficult to adequately interpret music clusters because music objects are highly perceptual and not so descriptive. So therefore, it's strongly desired to make music clusters conceptual. In order to realize such conceptual music clusters, we propose a notion of music formal concept. So our notion of music formal concept is based on formal concept analysis, which is a mathematical framework of data analysis and audio signal processing. So the fundamental idea of our formal concept is very, very simple. So music objects usually have two kinds of information, linguistic information and audio signal information. So linguistic information is often provided by assigning some tag labels, for example, artist name or composer name or genre. In addition, music objects are often assigned several tags by users of social networking services. So based on such linguistic information, we can consider terminological similarity among music objects. On the other hand, each music object has its own audio signal information. So from the information, we can extract various kinds of acoustic features by audio signal processing tools. So based on those features, we can consider acoustic similarity among music objects. So using both information, linguistic information and audio signal information, we try to obtain meaningful conceptual clusters of music objects. So from linguistic information, with the help of formal concept analysis, we can obtain conceptual clusters with explicit terminological interpretation. Then we use acoustic information as constraint in order to exclude undesirable conceptual clusters from the viewpoint of acoustic similarity. So as a result, we can obtain conceptual music clusters reflecting acoustic similarity. So before going into details, we first explain the key framework of formal concept analysis. So this is an example. Yes. In the framework, we assume relational data with respect to data object and attributes. And for example, data object lemon has three attributes: sour, individual, and yellow. Then we consider a set of data objects and their common attributes. So for example, in this case, lemon and banana share the attributes yellow. Moreover, Yellow is shared by only lemon and banana. That is, no other data object has attribute yellow. So in this case, lemon and banana and yellow forms a formal concept. And where the left object part is called the extent of the concept, and the right attribute part is called the intent of the concept. And the formal concept means that lemon and banana are similar because they share the same attribute yellow. So for another example, let's consider the lower example. So banana and grape. So they share the attributes sweet and clusterform. Furthermore, sweet and clusterforms are shared by only banana and grape. And that is, no other data object has sweet and clusterform. So therefore, banana and grape and sweet and clusterform forms are another formal concept. The concept means banana and grape are similar because they share the same attributes, sweet and clusterform. So just by finding all possible formal concepts from the data table, so we can observe various similarities among data objects. So from these observations, the extent of formal concept, object part, can be regarded as a conceptual cluster in the sense that it can be clearly interpreted in terms of attributes in the intent. So now let's consider a formal concept in case of music objects. Okay, so as is shown in this table, then each music object is assigned some labels like this: jazz instrumental 70s. Then for example, the data shows music one has each of the attributes jazz and instrumental and 70s. Then we consider a set of music one and music two. The both music share the attribute 70s. Moreover, the attribute 70s is shared with only music 1 and 2. Then the set of music objects, music 1 and music 2, and attribute 70s forms a formal concept. And the concept means music 1 and 2 are considered similar because they share the same attributes 70s. Thus, by finding formal concept in music object, we can obtain various conceptual cluster of music objects with clear interpretation in terms of their common attributes in the intent. So, however, we have some issues in finding formal concepts. As a general issue, so we often find a large number of formal concepts from a given object attribute relations. So needless to say, it's quite intractable to examine all of the extracted concept because the number is too large. So moreover, its computational cost would also be high. In addition, as a music-specific issue, so terminological similarity of music object is not always consistent with acoustic similarity. So here I would like to argue that music objects in conceptual cluster must be similar both terminologically and acoustically. So in order to realize such conceptual music clusters, we propose a notion of music formal concept. The music formal concept is simply defined as an ordinal formal concept satisfying a similarity requirement on extent. More concretely speaking, we can obtain ordinal formal concept from the incident relation of music object and their terminological attributes. And such an ordinal concept reflects terminological similarity. Here we assume each music object, Mi, can be represented as an acoustic feature vector, Vi, and such as MFCC vector and chroma vectors. So then we additionally require the extent of ordinal concept to include only acoustically similar music objects. So using a standard approach, we can easily evaluate acoustic similarity of music objects represented as a feature vector. The acoustic similarity between music objects M1 and M2 is evaluated with cosine measure for the corresponding vector V1, Vi, and Vj. Then for a given threshold alpha, if the similarity is no less than alpha, then we consider the music object M1 and Mj are acoustically similar. So it is noted here that based on the similarity relation, so we can construct a similarity graph like this, where each node is a music object and each edge shows a similarity relation between the nodes. So in the similarity graph, a click like this and complete subgraph, a click provides a set of music objects acoustically similar each other. So now we can formalize our problem of finding music formal concepts. So we are given incident relation R on music object and their terminological attributes. In addition, we are given an acoustic similarity graph G. Then we try to find every formal concept extracted in R whose extent forms a clique in the similarity graph G. Our algorithm for finding music formal concepts adopts a simple depth first search strategy. The basic operation is to expand the extent of just found formal concept. In our algorithm, a simple pruning rule is available. So we can enjoy powerful pruning based on a theoretical property of cliques in our similarity graph. Okay, now we present our experimental results. So in our experimentation, we use TagATune Dataset, which is publicly available on the web. And the dataset consists of about 25,000 audio clips in MP3 format. Then each clip is assigned several tag labels out of about 200 possible ones. So moreover, so each clip, we have 24-dimensional feature vectors with respect to their pitch and timbre. Okay, so first we present a music formal concept actually extracted by our system. In the music formal concept, the extent consists of 6 music objects, and all of which are commonly assigned the 6 tags shown in the intent. And listening to those music clips, we found the music concept provides a nice cluster in which they are certainly similar acoustically and have a clear interpretation given by the intent. Okay, so on the other hand, as a negative example, we show if formal concept rejected by our algorithm due to inconsistency of acoustic similarity. So for the concept, each music object of the extent is surely assigned the same tags in the intent. However, listening these audio clips, we found that we had an impression. That's my impression, but my impression that the music cluster given by the concept seems slightly ambiguous as a homogeneous group. For example, number 2 is right. This number 2 is a typical techno sound with clear beat of high tempo, while music number 5 is a illusional sound of synthesizer with no beat. So with the help of acoustic similarity, such an undesirable cluster can be excluded in our framework. So now I conclude my talk with a summary and future work. So I propose the notion of music formal concepts in order to realize conceptual clusters of music objects. So our framework is an extension of traditional formal concept in music domain, taking both terminological and acoustic similarity into account. In our experimentations, we verify that our framework can actually extract conceptual music clusters and reject undesirable ones. As a future work, we try to design some application systems based on the proposed framework. Okay, so thank you very much for your attention.